encryption and decryption. So if you are talking about encryption, right? So encryption is just to secure information, to change it to another form that people that are not authorized will not be able to access it. Unauthorized people will not gain access to it. So now, if you are talking about encryption, there are two kinds of encryption. There's the symmetric encryption and there's the asymmetric encryption. Now, if you are talking about this symmetric encryption, right, is a kind of encryption that uses the same key that it uses to lock or to encrypt in this case, is also the same key that it uses to unlock or decrypt. For instance, now, if your house, if you are going out, right, you find out that you want to lock your door. The same key you use in locking your door while going out is the same key you still come back and use to unlock your door while coming back from wherever place you went to. So that kind of encryption is symmetric encryption. So it means if I use symmetric encryption on any data, the same way I lock that data, for the person I'm sending that data to be able to unlock it, I need to send him the exact words I use. That thing particular that I used to lock it is the same thing I'm sending to him for him to be able to use to unlock it. So that's symmetric encryption. So pay attention. I will ask a question about this symmetric and asymmetric. So pay attention. Now, asymmetric encryption, this asymmetric now uses two keys. You have the public key and you have the private key. Now, the public key is what is used to lock it, whereas the private key is what is used to unlock it. So it's more like the public key is what you use to encrypt it. Anytime you see lock or encrypt, in this case, in this our case, we are talking about the same thing, encrypt lock. Why the private key is used to unlock it or decrypt it. Now, the problem with this asymmetric, not really a problem though, but it's just that it is slower than the symmetric, but it is more secure for sharing encrypted information than the symmetric. All right. So now let's take for example, for this asymmetric now, right? Let's say I have two keys. I have a door, and then that door now has place for two keys, whereas the first place is where I used to lock the door. But for me to unlock it, I need to use the second place. You know, normally doors just have one hole where you just insert one key and go. So let's just assume we now have a door that has two holes. One hole in particular is to lock the door, and the other hole in particular is to unlock it. So it means I'm going to have two different keys. So I can decide, so okay, in that case now, the key I use in locking that door is my public key. Whereas the key I use in unlocking the door will be my own private key. So if, for instance, I keep something inside the room and then lock the door, for anybody to be able to have access to what is inside that room, even if I give him my public key, that's the key I use in locking it, is useless to him. So the only way he can have access to that thing is when I now give him my unlock key. That's my private key. That's when he will be able to unlock and get whatsoever thing is inside the house. So now we talked about Caesar cipher, right? So Caesar cipher is a kind of encryption that depends on number of shifts. So it depends on how you actually configure it. You can configure it to shift by 2, to shift by 3, 4, 5, depending on what you want. So this one now we are looking at shifting it by 3. All right. So if you look at this first one, what we are having here initially is the encryption, and what we are having here is the decryption. That's why here you see downward encrypt, but upwards decrypt. So let's say this hello now. I want to say hello. I want to encrypt hello. What am I going to do? I'm going to use this first one here, this one above, to do my encryption. So now for hello, I'll look for H. Now, where is H? Look at H here. I will check what is linked directly to H is K. That means my H becomes K. I will check. The next one is E. What is my E? What is E linked to? H. So I'll come here and put H. The next one is L. Of course, the L is double L. So I'll come here and check L. What is L linked to? Is O. So instead of double L here, I'm having double O. And then finally, I'm having O here. Now, what is O linked to? Is linked to R. So if I encrypt hello using Caesar cipher, shift letters by 3, just like I say, you can shift the letters by 4, 5, 6. It depends on what you want. But we are looking at shifting the letter by 3. My hello becomes Keho. Now, let's say I sent this KHOOR to somebody, right? And then the person wants to decrypt it. He wants to understand what is the main message this person is sending to me. What he needs to do is to get this particular key I use in encrypting, right? Is to get this same key. You know, this is what I use to encrypt, all right? So him too, he will get this same key, and then he will use this key to decrypt it. How is he going to use it to decrypt it? Now he will come. What is here? Here is K. He will come to this bottom one and check what is K. Where is K? So look at K. K is pointing at what? H. He will come here and write H. Now the next one is H. He will come here and look for H. Where is H pointing to? H is pointing to E. He will write down E. He'll come here and check for O. Where is O? O is pointing to L. And here we're having double O. So we have double L. And then finally R. Where is R pointing to? Is pointing to what? To O. So you come here and put O. So you see now he has successfully decrypted what I've sent to him. And as a result, he will be able to understand the message I was trying to send to him. So now I want to ask a question. I have 2 questions. All right. Number 1, this Caesar cipher, is it a symmetric encryption or asymmetric encryption? So, and if it's a symmetric encryption, why? If it's asymmetric encryption, why? So you can please unmute and speak. Please unmute, like.
Let me give it a try.
Okay.
Okay. I feel it is it is symmetric encryption because it is the same key that is used to lock it.
Okay.
It is the same key that is used to encrypt it. It is that same key that will be used to decrypt it.
Okay. Okay. Beautiful. Beautiful. So don't mind me if I say beautiful does not mean it's correct. So please, any other person, like, is it symmetric? Is it asymmetric? If it is asymmetric, why? If it is symmetric, why? So one more person.
Yes, I think it's symmetric also because of it's the same key. You're using the same key to both to lock and then to decrypt, to encrypt and also to decrypt.
Okay. I love this. Beautiful. So you guys, you did well. So actually, it's symmetric. And why is it symmetric? Is the explanation is plain. It's the same key we use to encrypt hello. It's the same key we are still using to decrypt core. All right. So now I want to ask the final question. I also need 2 people, right? Okay, this time around I need 3 people. At least there should be a female among them. So now, which one do you think is better? Is it the symmetric or the asymmetric? And why do you think it's better? That's if you are in favor. Why, if you are not in favor, why do you think it's not better? Like, it's more like, okay, you can tell us, okay, what is the advantage? And you can decide to tell us, okay, what is the disadvantage? So can somebody please, anybody? Please, oh, you can go on. You know, I'm not seeing.
Okay, so let me pick asymmetric encryption to be the best because the transaction is done or cryptography is done for the general security of the chain. So if we want to have more security, as we've earlier said, then the asymmetric encryption should be applied in transactions so that the security will be much. Because in symmetric encryption, once someone finds like just one way of the encryption, he can decrypt. And if he can get the decryption, he can encrypt. But this one has to do with 2 keys, which are different. So I think it's more secured. My own take.
Okay. Beautiful. So any other person, I said remaining 2 people. So please, there should be a lady. Oh. If not, we'll just kick all the ladies in the house. We'll kick them out.
I can.
Okay, go on.
I also picked the asymmetric because, I mean, it's already saying here that it is slower but more secure for sharing, in the sense that it's different key. The
Okay.
public key locks and a private key locks it. So it is more secure. So I think I'll go with asymmetric encryption.
Okay. Okay.
And
Beautiful.
then the receiver can open it. So,
Okay. Beautiful. It's beautiful.
Let me
So,
let me try, sir.
okay, go on.
So for the symmetric encryption, anybody
Yeah.
that has the knowledge of Caesar cipher can
Yes.
easily decrypt it if he knows the shift concept that is attached to that key. While the asymmetric encryption, it works as a method of 2FA, whereby okay, you have access to the public key, but you still need extra factor authentication to gain access to the account or whatever you are trying to decrypt. So that is why asymmetric encryption is more secure and more reliable than the symmetric encryption. Thank you.
Beautiful. I love this class. Very engaging. Good. So now, the thing is, asymmetric encryption is very, very safe, despite the fact it's slower because you are dealing with 2 things here, but it's safer and better safe than sorry. All right. And when they say it's slow, it does not even mean it's something that will take you 10 minutes to. But it's just that, in programming, when you hear something is slow, it could be a difference in 1 second. So that is how useful timing is in software engineering. Because by the time you look at it, but it's just 1 second now. 1 second is small. Now imagine you are scaling that particular thing by 1,000,000. So imagine you multiply 1,000,000 by 1 second. You find out that it has now become minutes or even hours. All right. So, but that's just by the way. Now, if I don't know if it's true, but I heard of that. I'm talking about asymmetric now in real life. I heard where they said the ingredients they use in making Coca-Cola, right? Is it Coca-Cola or Coke this time around? Okay, I think it's Coke. The ingredient they use in making Coke is with 3 different people. Now, those 3 different people, right? They don't have all the ingredients. They only have parts. And those 3 different people, like, they don't travel together. They don't, if like they are going for a function, they climb 3 different planes. If they are going to anywhere, they climb 3 different cars. Why? All these ones is just for security reasons and security purpose. All right. So let's look at the next one, hash function. That's under cryptographic hash function.
So please, I have a question. Sorry.
Okay, go on.
Your previous slides. Yes, this shift letters by 3 in the Caesar cipher. Does that mean that is what is responsible for reshuffling the decrypted code, or what? What's the use of the shift letter?
Good. Now, just like I said, the Caesar cipher remains the same, but the shift can differ. Now, when they say shift letters by 3, it means that if you want to encrypt, starting from the first alphabet, you are going to count from the first, you count 3. That will be where you start your encryption from. So now we're starting from A. If we should count 3, that's B, C, D. So A will become D. B will become E. So you continue like that. Any place you reach Z, you start again with A. So if like they say, okay, we should shift it by, let's say, 5 and not by 3. Let's say the shift is by 5. That means from A we'll count. B is 1. C is 2. D is 3. E is 4. F is 5. So here we are going to start here by F. So it's going to be A to F, B to G. So that is what is meant by the shift. So you're actually correct. Do you understand?
Yes, sir. Yes, sir. Thank you.
Okay. You're welcome. So
Please, I have a question still on that slide.
Okay.
Okay. So, sir, in the context of blockchain, does it mean we are making use of this asymmetric in the sense that when we were treating kind of like a wallet, we have a private key and a seed phrase. So, does it mean this, how will I put it now, the public key is like
Yes.
the seed phrase, then the private key is like the private key in wallets?
Okay. Now to answer that, yes, in blockchain we make use of asymmetric encryption. All right, but then your seed phrase is also a private key. You understand? But it's just the alphanumeric. Should I put it alphanumeric? Okay, is the alphabetical part of your private key. That's why I see they always tell you that your key phrase should be kept private. Your key phrase is also a key. All right, but it's just that they encrypt it in such a way it use words, phrases. That's why they call it key phrase. It use phrases, and it could be 12, it could be 24. I don't think I've seen more than 24, but I think I've seen 12, I've seen 24. So that key phrase now will now help you to be able to import your private key into your wallet. So your public key is that, do you know your address, your wallet address? Your wallet address is your public key. But even your wallet address, right? Even that one has been hashed to give you an address. Is the hash of your public key that is your address. That's the one that you send to somebody. If somebody wants to send you money, you say make I send my address. You say yes, you now send it. So that's actually your public key. But that's not even the main public key. That your wallet address is actually a hashed public key. They hash your public key to reduce the length. That's what now gives birth to that your address, your wallet address. And but your key phrase is also your private key. So you are not supposed to share it. So does that answer your question?
Yes, sir. Yes, sir. Thank you.
You're welcome. You're welcome. So any other, don't worry. Let's see. Okay, before this week ends, we'll create a wallet and then we'll check the private key, because after you imported your key phrase, right? Although you can still import your private key directly, but in a situation where you are importing your key phrase, there's still a way you can go and check for your private key in the wallet. So you see that it's quite different from your key phrase. All right. So now let's look at cryptographic hash functions. So who can help us? What is a function? I believe almost everybody has an idea of what a function is before we now come and bridge everything together. So what is a function, if I may ask? Nobody's saying anything.
A function is an expression.
Okay.
That's like a concept that is an expression.
Okay. Good. So
In another context, the function is a set of rules that or codes that perform a particular thing.
Okay. Beautiful. So any other person, the last person, before we move?
Okay. It is just to describe a relationship between input and output of a particular thing. I can't really.
Okay. No problem. So now, of course, generally in programming, we all know what a function is, right? If sometimes when you know that, okay, I know this thing, but to put it in a way, in sentence, to put it together in sentences, it used to be difficult, right? So a function is just simply something that performs a particular, see me, I want to still say a particular function. A function is something that performs a particular task. All right. Let's say, for instance, in your calculator, you did addition function, subtraction function, multiplication function. Now, that addition function is a block of code, right? That can run addition operation. All right. So, and just like you people said, a function can take an input and then give you an output based on whatsoever logic you decide to use inside of the function. And there are also functions that don't necessarily require an input. And there are also functions that don't necessarily give output. So it all depends on your design and what you want to do. So, but hash functions now in particular, hash functions, they are functions that take in any input. If you like, give them 100 letters. If you like, give them 100 numbers. If you like, give them 1 million letters. They'll take it. And then they take that particular input and compress it. Well, I won't say compress, because when I say compress, it's like I'm looking at it that the input will always be bigger than the output. But the instance where you put just a little input and then the output is bigger than the input, right? So what I will just say is that it takes whatsoever you give to it and then turns it into a fixed length of string of characters. And when they say string of characters, it includes letters from A to Z, both uppercase and lowercase. It also includes numbers from 0 to 9. So do we get it? Now, why you see I mentioned SHA-256 here is because this is one of the most popular hash function. There are other ones. There's KCAP 256. That's the one used by Ethereum. This SHA-256 is mostly used by Bitcoin, but I believe there are also other blockchains that makes use of it. All right. So it means that irrespective of what we put in this hash function, it will always return a 64 length of letters or number. That's for SHA-256. There are other kinds of hash functions, and they too, each of them have their own length, particular length. So now, say it's a one-way process. You can't unhash it to get the original input back. So one interesting thing about this hash function is that once you hash something, it is impossible to unhash it. I believe some of you must have heard of reverse engineering. It will be hard to take the result of your hashing and work it back to get what the input is. So that is one beautiful thing about this hash. All right. So not part of the class, but just, I don't know if you guys have started hearing this recent technology that is trying to come in. I feel we'll talk about it later. So, but that's just hash function for you. You can't unhash it. In fact, right now it is mathematically impossible for you to go back. They always call them one-way functions. So take note of that. Now, let's look at properties of a good hash function. This hash function I'm talking about, you can create your own. Though. It's not that it's something that is like magic, something they just use abracadabra and do and say, behold, our hash function is here. It's something you can create. All right. So now let's look at, if you are creating a hash function, what are some of the things you should look out for? What are those things that are very important, right? So number one, deterministic. When they say deterministic, it simply means if you call the function 1,000 times with the same input, that 1,000 times, it should give you the same output. The output should not change. It should be the same. No matter the number of times you call that function with a particular, so while you are calling it with that same input, it should always give you the same output. The second is fast. Your hash function should be quick to compute. That's compute. It should be quick to convert whatsoever you give it to that fixed length of string of characters. The reason being that somebody that is mad enough, you might not be mad, but somebody that is mad enough or crazy enough, he can decide to say, really, these people have not seen anything. Let me give this thing 10,000 characters and see if it will do its work. You understand? So it needs to be fast. Another thing is collision resistant. Now, for those of you that are into programming, probably those that are into C programming or Python, any of this, you must have something like hash maps and all of that. Now, all those hash maps, all those data structure that have to do with hashing, there's what they call collision. Collision simply means where the same input or where different input will give you the same output. So now your hash function should be collision resistance. That is, like every input, every unique input should give a unique output. You shouldn't say, I put AAAB and I put AB and I'm having the same result. No. No. So a good hash function should be collision resistant. That's zero collision. Then next, pre-image resistance. Now, you see, they call it pre-image resistance. You know what an image object, you as an object, you as a person, if you want to see yourself, where do you go to? You go and stand before a mirror. A mirror will reflect your image. All right. So it means from an image, I can know the person that is standing by the other side. I need not see the person face to face. I can look at the reflection on the mirror and then know that, oh, this person standing behind the mirror is a boy, oh, this person is a girl, oh, you understand? So your hash function, it should be impossible to reverse engineer. Somebody should not be able to get the input from the output. And then finally, small changes should give big impact. Not that if I put A and I put AA, in alphabet, it looks small. So I just A I add to RAM now, nothing there. Now, if I put A and I put AA, the output should be so distinct that somebody will not even suspect that the difference between the two inputs is just one letter, which is letter A added to one. So that is what it means by small changes and big impact. So let's look at example of this. All right. Now, if we take the input Fox and we pass it through a cryptographic hash function, you can see what is giving us as an output here. Now, let's go to the next one. If we pass in the red fox jumps over the blue dog, right? And then we pass it through a cryptographic hash function, you can see. Now, do you see the difference? Do you see how vast the difference is in the output between these two? Now, let's even do this again, this same one, but this time around, the only thing we are changing is instead of V in the over, we are changing it with U, and we are passing it through a cryptographic hash function. So compare the output. You can see the output is way different. In fact, from this output, you will never suspect that the only thing that was changed here is just the V that was changed to U. So this shows the property, this particular property of a hash function. Small changes, big impact. So any question before we move on?
Please, I have a question. Will this slide will it be sent to us?
Yes, definitely. It's for you people. It's not for the teacher alone. Yeah. So any other question? And please go on. Like somebody is raising up their hand.
All right. For this slide, it will be shared on the Discord resource channel. So just ensure you're on the Discord channel. You'll get the slide there after the class.
All right. Thank you. Thank you, Ebul. All right. So let's look at some common hash functions, because here we have been talking about hash functions. So let's look at some of these common hash functions and know what they are. Now, there are basically two common types of hash functions used in blockchain. When you hear they say two common, does not mean that's the only hash functions existing. It's just that those are the ones that are being used the most. All right. The first one is the SHA-256, which I've talked a little about it before, where I say it's being used by blockchain, by the Bitcoin blockchain, SHA-256. And there's another one called the KCAC-256. So this KCAC-256 is the one used by the Ethereum blockchain. All right. Now, both of them are similar in terms of operation. Now, in terms of operation, in what sense? Both might be using two different algorithms, but all meet all these properties, all these conditions. Both are deterministic, both are fast, both are collision resistant, both are pre-image resistant, and then both, for any small change, it will give a very big impact. So take note of that. So hash functions are useful in creating hashes, of course, and these hashes link. So take note of that. The output that is being given, that's once you send an input to a hash function, the result is going to give you as an output. They are always called hashes. So take note of that. So hash functions are useful in creating hashes, and these hashes link blocks together, where each block contains the hash of the previous block, hence securing the data integrity of each block. So now I want to ask a question, right? So before I ask a question, look at this diagram. So this diagram is trying to illustrate this property of the hash function. That's the one that can't be reverse engineered. So you can see from this image, we give it data of any size, pass it through the SHA-256 function, and then it gives us an hash output. But from the hash output, it's impossible for you to get what the input is. And just like I say, in mathematics, they call them one-way function. One-way function. So take note of that. So now, I want to ask a question. Two questions. One will lead to another. I believe last week you guys did blockchain, what a blockchain is. So I want to ask, what is a blockchain? Don't worry, you can use Pidgin, Yoruba, Igbo. We always have people that can interpret. So what is a blockchain? Okay, go on. So, I think somebody is raising up their hand, right?
Can you hear me, sir?
Yes, can hear you.
Okay. I can say that a blockchain is a digital record of digital blockchain is a digital record of data of
Okay.
chains blocks
Okay.
that are stored in a network of interconnected computers.
Okay.
So ensuring security and transparency by making it impossible to alter or change after storage.
Okay. Beautiful. Beautiful. Thank you for that. So now, you heard what he said, right? Blockchain, digital record, right, of data. And now that digital record is being stored in such a way, it will make it impossible to change it. All right. So that is where hash is coming into. Now, why is it called a blockchain? It's called a blockchain because each of those blocks are connected to one another. So block 1 is connected to block 2. Block 2 is connected to block 3. So that's why they call it chain. You know, if you chain something, everything is connected. If you look at how a chain is, one link is connected to another link is connected to another link. So that's why they call it blockchain. Each blocks are connected. And now that block, a particular block contains informations, which could be transactions, could be data, could be any other thing. Now, the whole information of that block is taken and is being hashed. And that hash now will now be linked, included. The next block that will be like connected to that previous block. The hash of that block will now be added to the next block, will be added to the next block. And then the hash of the previous block plus the transaction of the present block will be carried again. And then will be hashed. So like that, like that, like that. So you can see that, number one, since all the information is being hashed, you can't even say you want to go and unhash it, and then you now start changing some of the information in the block. And then somebody might ask, why would somebody even want to do that? Now there's something they call double spend, all right, in blockchain. Now, what is double spend? I have 10 naira. Sorry, let me know it's small money. I have $100, right? And then I'm sending $90 to George, Sir George. Now, if I'm sending $90 to Sir George out of $100, how much is my change? How much is remaining? Somebody should help us. How much is remaining?
10.
$10, right? So, and then come back and say, God, let me send $50 to Shama. Is it possible?
It shouldn't
No.
be possible.
It's not possible, you understand? So that is one of the areas where hashing those information helps. If not, somebody with a lot of computing power and all of that, right, can go back and rewrite the transaction he has done. Since I've sent $90 to Sir George, I can go back and this $90, I beg, I'll go and rewrite it to 50. So if I rewrite it to 50, it means now I'm having 50. So since I'm having 50 now, I should be able to send that $40 to Shama. So, but that's just by the way. Now looking at SHA-256 and KCAC 256. SHA-256 is actually used in blockchain, in Bitcoin blockchain, and then KCAC 256 is used in the Ethereum blockchain. So take note of that. So the SHA-256, that's why I see they call it. Now there are different kinds of SHA. It's not only 256. There's 512. There's I think 128. All right, but this is the one that is used for the Bitcoin. Now this SHA-256, it produces a 64-character hash. So irrespective of what you give it as an input, it will always give out a 64-character hash. We'll still do an illustration of this. So we'll count it to be sure that that's what is actually giving us. That's giving us that 64 character is what is actually giving us. So whereas the KCAC 256 is also similar to what this one is doing, but it's just that it has a different design, but they do the same thing. So any question before we move to the next slide?
I have a question, sir.
Okay, please go on.
So for clarification purposes,
yes,
I want to assume that if someone has, let's say, an average of 20 blocks of transactions, it's possible for him to be able to, okay, if he wants to find out the information on the 5th block, with the hash of the 20th block, he can have access to the 5th block, right?
Yes, but what he has to do is that he has to follow it sequentially. All right, he has to follow it sequentially. That's sorry for that. Okay, so he has to follow it sequentially. What I mean by sequentially is that from the 20th to get the information of the 5th block, from the 20th, he has to walk down to the 19th, the 18th, the 17th, like that, down till he gets to the 5th block. All right? Because it's a chain. So you can't like jump, from 20, say, go to 5. Say, I don't arrive. Say, no time. Now jumping levels we did. Because the 20th block, the details of the 19th block will be hashed to the 20th block. So we need to go back to 19th, and then from 19th to we'll go back to 18th, and we'll keep going back like that until we get to the 5th one. All right. So that is actually what is happening. Of course, you can use a block explorer to get information directly, but obviously that's how it works. So I don't know if that answers your question.
Yes, it does. I was just wondering if there's no technology or there's no function that can make it easier. Like, just do this. I want to get the 5th block. Input one particular function and just bring it out.
Okay.
Like in a case of having multiple transactions that is over 1,000 or 2,000.
Yes. Yes. You can make a function that does that, but inside of that function, what function just helps to do is that it helps to make things less complex. It covers a whole lot. You understand? So now, just like I was saying, you can create a function that does that. But then inside of the function, at the end of the day, what the function will be doing will still be going from block to block to block until it gets to your destination. You can decide to say, okay, this is the present block, block 20. This is the target block, block 5. Now, I want to get information of block 5 from block 20. And then the function will do the work of moving down the block for you. So your own is just to impute target, impute current block, impute target block, and then the function will give you answer. But inside of the function, you must follow this line of chain. So does that answer your question?
Yes, sir, it does. Thank you.
You're welcome. So any other person? Any other question?
Yes, sir. Yes, sir. Yes,
Okay,
sir.
please go.
Okay, sir. Sorry, I want to understand something. So, let's say this hash function now, let's say it's stored on a blockchain. Its own function is to produce something like 64 characters. So, are we saying the cryptography is just like, let me use example, we coming from a Web2 background that write JavaScript and
Yes.
function. So these things, they are just like a function using cryptography to write the logic.
Okay, please, can you come again? Sorry.
Okay, so like what I'm trying to ask now, let's say this hash function now, it
Yes.
produces 64 character whenever it is called. So let's
Yes.
say in the context of Web 2 now, if you are writing a function that produces 64 characters, so does it necessarily mean that the cryptography is just like a language or something that uses this hash function to produces 64 character that is stored on the blockchain?
Yes. 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 So all these things, they are functions. All right. They are functions. They are mathematical functions. And it's not as if it's a function that nobody knows. SHA-256 and KCAC-256, they are open source. You can go and check how they work. Like, it's in the open. You can go check how they work and all of that. But it's just that, unlike the other functions, you can't walk back. You can only walk forward. Forward ever, backward never. So does that answer your question?
Yes, yeah, thank you.
All right, you're welcome. So any other one before we move?
My question is, why does this thing use more of hashing instead of encryption?
Instead of
Encryption.
Okay, good. Now, the reason why it uses hashing is for the sake of data integrity. So once you hash something, you are sure that is what you hash that is there. Nobody can change it. Why? Because based on law of hashing, you can't go back. You can only go front. You can't go backward. You can only go forward. But for encryption, you can go backward. By going backward, encryption, you can decrypt and go backward. And if you are decrypting an encryption, it means you can get the original information whatsoever and then change whatever thing you want to change there. Which of course is one of the things that blockchain are looking at, which is to secure your information and make it like you not be able to change it. Once it has been verified and placed in a record, but public record, right? That's the blockchain, because blockchain is a public record. When it has been done, verified, and shared in the public record, nobody can now go and change it. So that is why they are relying more on hashing. All right.
Sorry, a quick one. I want to ask, does that mean hashing is not a type of encryption?
Let me throw the question to you. Do you think it's a type of encryption?
I don't think it's a type of encryption.
Okay, why? Why don't you think so?
Because I may not be totally correct. It is available to the public. It's just that you can't make changes to it.
Okay. Okay. So let me ask another question, right? Before I will give my own answer. So what is encryption to begin with?
It's securing information.
Good morning, guys. I feel like
okay, please go on. I think somebody is speaking.
Okay, I said I feel like encryption and hashing are closely related since they follow the same concept, which is to secure a form of information or data or whichever item or something you have. So if there is a difference, it should just be the way each of them works. For encryption, like for hashing, like you said, you can't go back. You have to be sure that this is what it is, this is what it is. You cannot go and tamper with the original information. And like also what you said for encryption also, there's a possibility of you going back, decrypting it, and also further encrypting it again. So they are closely related. Hashing is also a form of encryption.
Okay. So any other person? This class is interesting. I'm learning.
Encryption in my own way, like, it's converting plain text to ciphertext, whereby that text will be unreadable. It will not be able to be like accessed by unauthorized user, only by the person who encrypts it.
Yes. Okay.
So I also say something. Sorry. What I feel about hashing is like having a stamp to a document.
Yes.
That is what I feel about hashing. While encryption is having a key to a room. Hashing gives the verification. That is what I generally feel. They are closely related, but I don't think they are the same.
They are the same. Okay. So any other person? This class is interesting. Wow.
So I would say the hashing is maybe a different function that works like encryption, but why they call it hashing or a system hashing is that you cannot decrypt it. It's not a decrypt function or a format. Once you encrypt it, is encrypted.
Okay. Somebody's raising their hand. Please go on.
Okay, so I answer that hashing is not encryption. But as the name implies, from the definition you gave us, say that hashing is a kind of turning a large length of character into a fixed length of string. So hashing is not encryption. Encryption is basically a kind of locking up the data in the sense that the person that does not have any access or authorized key cannot access the data.
Okay.
They are kind of a few different.
Okay. I love this discussion. So what is going to happen right now? I'll give you guys an assignment. Go and make in-depth research. That's assignment 1, because you still have other assignments. And tomorrow, we'll discuss it tomorrow. Before we start tomorrow's class, we'll discuss it. Go and check. Hashing, is it an encryption? If it is, then what kind of encryption it is? Or why is it an encryption? And if it's not an encryption, why is it not an encryption? So I'll stop there. Interesting. All right. So we'll be looking at public key cryptography and digital signatures. I'm very happy somebody mentioned something while he was trying to talk about is hashing an encryption or not. He mentioned stamp. All right. Please, who is that? Who mentioned stamp?
I'm the one, sir.
Good morning,
Michael.
Beautiful. So we'll look at, probably we'll relate stamp to something here, but let's just start. Now, we'll be looking at public key cryptography. Okay.
I didn't have a time saver. I would have called back.
Can somebody help me to mute this mic, please? Okay. So now we'll be looking at public key cryptography and digital signatures. So what are keys? And when we say keys, most especially in this case, we are talking about public key and private key. All right. So of course, we've talked about them here. I think we just said a little under asymmetric encryption, not really much, but at least. So now, in the context of blockchain and cryptocurrency, now mind you, public and private keys not only the concept of blockchain, other things too, right? Other things too have a kind of public and private key. But we are looking at public and private key in the case of blockchain. So in the context of blockchain and cryptocurrency, keys refer to cryptographic keys, specifically public and private keys that control access to and ownership of digital assets. Now, when you are talking about these keys, there are two kinds of keys. You know, here we talked about, when we are talking about symmetric encryption, we talked about this Caesar cipher, where we say we use this as the key both to encrypt and the key to decrypt. But of course, you know, public and private make use of asymmetric encryption. So the public key is used to encrypt, while the private key is used to decrypt. So let's check. Now, public keys, this key can be shared publicly, just like I said before, as it doesn't grant access to your fund or access. 2, it allows others to send you cryptography or other digital assets. So just like I say, if for instance you need somebody to send you maybe Bitcoin, to send you Ethereum, to send you USDT or any other digital asset, you can just copy your public key or your public address. Now I told you your wallet address is always derived from your public key. It's a compressed form of your public key. So you can share it with anybody, and then they having that one does not mean, it's just like you sharing your bank account with somebody, your bank account number. It does not give any, that person having your bank account number can't even know how much is your account. He does not even know access. He does not have access to your account by just the account number you gave to him. All right. So that's the same thing too with public key. So public key is the one you share publicly, is the one you use to receive digital assets. All right. Whereas private key, this should be kept secure. That is not something you want to share with anybody. And when I mean anybody, I mean even if you are a twin, you have a twin, you don't share it with your twin. You don't share it with anybody, right? Not that because your twin will go and withdraw your money, but it's that your twin can misplace it and somebody will see that your private key and use it to go and withdraw your money. Nobody can keep your thing more safe than you. So take note of that. So this should be kept secure as it is a secret, an alphanumeric code that acts as a password, or in a more better term, signature, to authorize transactions and prove ownership of the corresponding public key and its associated funds or assets. Right? Now, just like your banking application, for the fact that you know your account number does not mean you are the owner of the account number. If you can't log into your bank app with the username and password, or if you go to the bank, if you can't prove that you are the owner of the account using your BVN and NIN, there's no way they can do anything about your account. So that is what private keys are too. Private keys are your access to your digital asset. That is what will give you access to it. If, for instance, now you want to send something, maybe a Bitcoin, Ethereum, USDT to anybody from your account, is your private key that will prove that that money you are trying to send is you that owns the money and not somebody else. So private key proves ownership. So take note of that. So for those that have probably interacted, done a kind of transaction, even those that used to farm, I know some people here, they must have farmed Telegram TG, Telegram, all these Telegram airdrops, right? So, sorry. So they must have farmed, what's the name? Telegram airdrop. I can see somebody is laughing. You people must have farmed Telegram airdrops. So at some point, you find out that there are some things they'll ask you where they'll say you should grant access. All right. Now, I know some of you might not even read what is there. You say, I beg, these people go soon launch. They say connect wallet. And when you go to connect wallet, you see they will like, there's something that will pop up where you see accept, decline, where you now accept, right? Now, what they are trying to check is, are you really the owner of that account you are connecting the whatsoever airdrop that you want to connect? Are you really the owner of the account? So by you accepting now, what they are doing is that they will use your private key to sign, to prove that you are the owner. So that is just what it is. Private keys. So any question before we move forward?
I have a question, sir.
Okay, please go on.
So over the years, there have been several scams online where people lose their funds to all these kind of things, like all these Web3 technologies that, okay, they see a particular airdrop that they want to maybe participate in. Then the developers of these airdrops, they send them a particular link, they click on the link, and it gives them access to the wallet. So these people, having gained trust in these developers, they will now click on the accept. So now what you are saying is these developers already have access to their private keys, right?
No. The developers, right, don't have access to your private key. They only have access to it when, because some of them, what they do is that they write malicious programs. Malicious programs simply means programs that they do some kind of hidden things that you don't know. All right. So by interacting with anything, maybe they send you something and then more like a transaction and you accept. In that process of accepting, there's a way they can do and get your private key or gain access to your wallet to now do their whatsoever activity they want to do, maybe clear your wallet, transfer the funds in your wallet, and all of that. So if you don't accept, there's no way they can have access to your private key. So that is one of the ways they use in getting your private. And those programs, just like I said, they are malicious programs. Whereas probably in the programming of that program, once you sign or you accept, it will automatically pick your private key, because your private key that you use in signing. So it means once you are signing anything, your private key will come up because it's the one that is doing the job. And then the process, they can decide to like pick it up and then do whatsoever thing they want to do. So that's actually, to the best of my knowledge, though it's not as though I'm in the security aspect of blockchain.
Okay, I want to confirm something. So it goes as far as cloning a website, making it look like your original website, then doing all those malicious practices to the person's wallet. Am I right?
Yes, it goes as far as that.
Okay, sir. Thank you, sir.
You're welcome. And I think of recent, I saw somebody wrote where one of his wallet got cleared, and funny enough, what they even used was a Zoom link, right? Where he joined, they came like they were investors wanting to invest in his business, and then like that, they sent a request, and then they asked him to respond, to sign the request and all of that, and he accepted, and that was it. It was not even up to 5 minutes. They cleared everything. So that's why you have to be careful of the website you are interacting with. Because if they don't clear the money immediately, they might have access to your key, which later they can go and clear it. So you have to be very, very, very careful when it comes to interacting to websites. You have to be sure that it's a genuine website. You have to check and all of that. So any other question?
Yes, to still add on these attacks, I think I was reading something and I came across the 2 attacks, and one of the attacks is on your public key. Like those hackers will try to hack your public keys. So they will be trying different keys until they find a key that can actually match your key, and then they will attack. And the other attack, I think, called man in the middle attack, whereby someone is in between the peer-to-peer, that is those people involved in the transaction, so that then he will hack it and then clear your funds. I think there are materials that they can actually read on that.
Okay. So you can go and then get more information on it. All right. Okay. So let's look at, so any question on this before we actually move forward? So it means if you lose your private key, there's no way you can prove that the digital asset, the money, the crypto, whatsoever thing you are having, there's no way to prove that it's for you. So it's gone. Like when I mean gone, I mean gone. So, and this is strictly for decentralized exchange, DEX. But because for centralized exchange, you only need your email and your password. Like your Bybit now, I don't even think there's any place to save your key phrase in Bybit. Just need your email, your password, and boom, you are in. So all those ones are actually centralized exchange. But when you're talking about real decentralization, blockchain itself, decentralized exchanges like Trust Wallet, your MetaMask, once you lose your private keys or your key phrase, that account is gone. There's nothing you can do about it. All right. So let's look at how these public-private key pairs work. Although the diagram is also here, right? And then we also have the same thing. So how they work. Now, every user has two sets of keys. The public key, which is the one he can share with other people, because that's the only way he can receive digital assets from others. And two, the private key. That one is the one he has to keep secret. And that's the one that's used for signing transaction. In fact, some people will tell you that some people even go to the length of having a hardware key. All right. You know, your private key is digital, a number. Some people go ahead to even get a hardware wallet. So that hardware wallet now, the only way they can sign transaction is when they connect the wallet to the hardware, this thing, to their computer. That's the only way they can sign a transaction. So all those are just for security purposes and reasons and all of that. Since your computer is hackable, somebody can hack your wallet, but that hardware wallet now is very much unhackable because everything online, there's a possibility of hacking it. So far is on the internet, but the hardware wallet now is not existing online, it's offline. And it's just that anytime you want to perform a transaction, you connect it to the online wallet interface, carry out your transaction. Once you are done, you remove it. Yes. So when someone wants to send you a secure message, they encrypt it using your public key. As a result, only your private key can decrypt it. So, for example, when someone wants to transfer an asset or fund, he sends it to our public key, of course. On the other hand, for us to be able to access that asset or fund, we will need to prove using our private key that we are the owner of the asset or fund that was sent to the public key. So, do you understand? Do you guys understand the scenario? How it works? Now, look at this diagram. We have a sender. And then the sender takes a plain text. Now, mind you, this plain text, it can contain transactions in it. Because I know some people will be thinking, transaction, how? So you mean they write? So if I want to send Bitcoin now, you know, I know the kind of picture some of us have is that if somebody is transferring Bitcoin, the Bitcoin is to be like coin. They'll just transfer it to your wallet. So that's why they call it. All right. So that's why they call it digital asset. So if you are transferring 0.1 Bitcoin to somebody, the 0.1 will be written. You know, just like the way you write 0.1 on a piece of paper, that's how you write the 0.1 too. There's no difference like that. Amount 0.1, sender, receiver, and all of that. Sender address, also receiver address, and all of that. So now your public key will do the encryption. It will encrypt it. And then now what you now have will no longer be a plain text, but a cipher text. That's a text that has been encrypted. And then why does he have to encrypt it? Mind you, if he's sending the asset, he's sending it to your public address. So it means that he's encrypting the encryption. In the encryption is contained your public key. So it combines your public key with whatsoever thing he's sending, send it. Once he send it, right? Why does he have to encrypt it? He has to encrypt it because if he doesn't encrypt it with your public address, any other person can come and claim it. So he doesn't want that. That's why he has to encrypt it. Now, encrypting it now, for you to be able to decrypt it and get whatsoever thing that is inside of what is in this transaction, right? You need to use your private key to decrypt it. Now, once you're able to decrypt it with your private key, that's when the information that he encrypted will now be decrypted. And then that's when you'll be able to get that information. So that is the process, or that is how public-private key pairs, that's how they work. Sender takes your public key, combine everything in what he wants to send to you, encrypt it, send it. Once it gets to you, you have to prove that you are the owner. You have to prove that what you receive is meant for you and not for somebody else. How do you do that? By using your private key. You use your private key. If truly that thing is being signed with your public key, your private key should be able to decrypt it. If it's not signed with your public key, it means there's no way your private key can decrypt it. You decrypt it back to plain text, and that is only when you can actually get whatsoever is being sent to you. So any question?
I have a question, sir.
Okay, please go on.
So I want to ask, what is the advantage of using a public key to send coin over using wallet address? Since wallet address is derived from public key, why can't I just send my wallet address to the person and not have to start authorizing again with my private key? So I want to know the advantage of using the public key over the wallet address.
There's no advantage. Now, just